So in this video, we're going to continue our problems from exercise 8.4, and in this video, we're going to see problem number 5. Let's read what the problem is. Prove the following identities where the angles involved are acute angles for which the expressions are defined. So they have given us a total of 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. A total of 10 expressions are given in this whole problem statement number 5, and each of this expression is in the form of an equation. Okay, we have a left hand side and we have a right hand side, and we have to prove in each of this problem that left hand side is equal to right hand side. So there are multiple identities given here, which I've hidden in this box. We'll first start with the problem number 1. So let me zoom in. Okay, so it reads, let's try to read: cosec theta minus cot theta the whole square is equal to 1 minus cos theta divided by 1 plus cos theta. Okay, so again you look at this as an equation and you start with left hand side and then you solve and then you come to the right hand side. So we are while doing this, we are going to use all the possible properties that we have learned in this entire chapter of trigonometry, right from the beginning, right from the different identities that we had, the different conversions, the complementary angle property, everything, each and every possible property we are going to use to prove that left hand side is equal to right hand side. So let's begin. So here left hand side LHS is equal to, I'm going to just rewrite, cosec theta minus cot theta the whole square. Now typically while solving these problems, what we do is we convert all these trigonometric identities, sorry, not trigonometric identities, trigonometric ratios, all these trigonometric ratios into our basic sine and cos. Always remember, sine and cos are our basic foundational trigonometric ratios. So if we convert these into sine and cos, something might come up. So let's try to figure that out. Okay, so that is equal to, this is going to be 1 upon sine theta, because cosec theta is 1 upon sine theta, minus cot theta is cos of theta upon sine of theta. Okay, and this is the whole square. Now let's try to solve the equation. The inner inside the bracket, you can say this is subtraction, a minus b. The denominators are same, sine of theta. So I'm going to just continue that. So this will be 1 minus cos of theta, and our denominator was sine of theta. And don't forget the whole square. Okay. So now what I'm going to do is I'm going to distribute this square. So now what we're going to do is we're going to distribute this square over the numerator and the denominator. So this is equal to 1 minus cos theta, okay, the whole square divided by sine of theta the whole square, okay, and that is equal to, we can just write this as 1 upon 1 minus cos theta the whole square as it is, and I'm just going to write this as sine square of theta. Okay, sine theta the whole square is equal to sine square of theta. So this is our left hand side that we have reached to. Now let's go back to the question. Now in the right hand side, you can see we have 1 minus cos theta. Here we have got 1 minus cos theta, and this is 1 plus cos theta, whereas here you have sine square theta. So we are going to use, so now this we have here is sine square theta, but we want something like 1 plus cos theta. So everything is in cos theta in our right hand side. So thinking in that direction, what we are going to do is we are going to first use our identity. So let me note down the identity that we have, a very basic identity, which is sine square theta plus cos square theta is equal to 1. Okay, and therefore I can say from this identity that sine square theta is equal to 1 minus cos square theta, right? So let's substitute this identity to this denominator. So we are going to, okay, let me draw an arrow here. Yes, so from this identity I'm going to say this is equal to 1 minus cos theta the whole square divided by 1 minus cos square theta, okay, taken from this identity. Now if you focus on this expression that we have here, let's focus on the denominator. The denominator is 1 minus cos square theta, which can be written as, I'm going to rewrite it, which can be written as 1 minus cos theta the whole square, numerator as it is, so don't worry about the numerator. If you focus on the denominator, this can be written as 1 square minus cos square theta. Okay, 1 can be written as 1 square minus cos square theta. And once again we have another identity which is of the form a square minus b square, which can be written as a plus b, okay, into a minus b. And now again using this identity a square minus b square, I am going to rewrite the denominator. So the denominator is going to be 1 minus cos theta the whole square divided by a plus b, which is 1 plus cos theta, and a minus b, which is 1 minus cos of theta. Okay, so again focus that our aim was to start from the left hand side. We started from the left hand side and look at the right hand side. The right hand side is of only cos theta. So keeping that in the mind, we tried to convert everything into cos theta, cos theta, cos theta. And finally we have arrived at this point. And now we all know that this, let me use a highlighter. So this is 1 minus cos theta, this is 1 minus cos theta the whole square. So they will cancel each other out. And what we get is 1 minus cos theta on the numerator, and denominator this remains as it is. Okay, 1 minus cos theta remains as it is. So I'm going to write here, sorry, 1 plus cos theta. So I'm going to write here 1 plus cos theta, that remains as it is. And this is nothing but our right hand side. Okay, so a little bit lengthy problem, but if you keep a little bit of patience and just focus on the very basic situation, focus on the basics. The basic of any trigonometric ratio problem is that you convert the given expression into sine and cos. If you convert the things into sine and cos, it's very easy to figure out. So we started from, yes, so we started from left hand side. It was cosec and cot. We started with cosec and cot, and everything was converted into cos of theta. So 1 minus cos theta, 1 plus cos theta is what we got here on the right hand side. Thus LHS is equal to RHS. So this is how we have solved problem number 1. Okay, now let's erase all this and go to problem number 2. So all these problems in this question number 5, you can see there are total 10 identities. All of them are a little bit complicated and they will need you to be a lot of patient. You have to solve each and every step carefully, and it's going to be a little bit lengthy problem. No need to give up or no need to get confused. Just focus on the basics, follow the pattern that I have told you, convert everything into sine and cos, and keep on solving. Now once again we have an expression here or an equation here. Let's read it. Cos A divided by 1 plus sine A, and 1 plus sine A divided by cos A is equal to 2 of sec A. So once again we are going to do the same thing. We start with left hand side. Okay, let's use a different color. Okay. We are going to start with our left hand side of the equation, and we are going to solve and see if we get the right hand side. Okay, so left hand side is fortunately given in terms of sine and cos already, so no need to convert anything. So 1 plus sine A the whole divided by cos of A. So now we are going to do our regular addition of fractions. Okay, this into this plus this term into this term, the whole divided by this into this. So let's do that. That is equal to cos A into cos A is cos square A, plus this is 1 plus sine A the whole square, because 1 plus sine A into 1 plus sine A, and the whole divided by 1 plus sine A, okay, into cos of A. Okay, now let's focus on the numerator and let's try to solve the numerator. There's nothing to solve in the denominator, it's just this term into this term, so let's keep it as it is. So this is going to be, okay, this is going to be cos square A, and we all know what is A plus B the whole square. I'm just going to make a note of that quickly. So okay, we have A plus B the whole square as equal to A square plus 2AB, okay, plus B square. Yes, so we're going to use this expression here. So A square, which is 1 square, is 1, plus 2AB, so 2 into sine A, plus sine square A, okay, sine square A. The whole divided by denominator remains as it is, 1 plus sine A into cos of A. Okay, and now as you can note down in the numerator, we have cos square A and we have sine square A, and we all know cos square A plus sine square A is equal to 1. So let's substitute that. So 1 plus 2 sine A as it is, the whole divided by 1 plus sin A into cos of A. Okay, and oops. So now we have 1 plus 1 is equal to 2, so that is equal to 2 plus 2 sin A, the whole divided by 1 plus sin A into cos of A. Now 2 is common in the numerator, so I'll take 2 out of the bracket. So we are going to have 1 plus sin A in the numerator, and denominator we already had 1 plus sin A. So those two terms are going to cancel each other out. Okay, let me use the highlighter. This and this, they are going to cancel each other out, and what we are going to have is equal to 2 upon cos A. Okay, but what is 1 upon cos A is equal to sec A, so that is going to be 2 into sec A, and which is our right hand side. Yes, so once again, this was our right hand side, 2 sec A. So we started with the left hand side, solve, use different identities, use this cos square A plus sin square A trigonometric identity, solve, and we reach to our right hand side. So LHS is equal to RHS, and that is how you solve these equations. So once again, let's get rid of this. Okay, and now let's focus on our problem number 3. Now let's reveal the problem number 3. This is our problem number 3. Yes, let's read the problem. So LHS is, let me zoom in. Okay, LHS is tan theta divided by 1 minus cot theta plus cot theta the whole upon 1 minus tan theta, and that is equal to 1 plus sec theta into cosec theta. Okay, so it's a lot of terms here on our left hand side as well as on our right hand side. We are given a hint by the question that write the expression in the terms of sin theta and cos theta, which is exactly what I have been telling even in the previous two problems. All you have to do is very simple, very straightforward. No need to use any logic or no need to use any extra fancy things. Just convert LHS into sin theta and cos theta. Okay, so we are going to begin with that. Now first let us note down what is LHS. So LHS is equal to, this is tan theta the whole upon 1 minus cot theta plus cot theta the whole upon 1 minus tan theta. Okay, so let's convert them into their basic sin theta and cos theta as we did in the previous problems, and as mentioned by this hint as well. Okay, so tan theta is sin theta upon cos theta, and cot theta is cos theta upon sin of theta. Okay, plus again cos theta divided by sin theta the whole upon 1 minus sin theta upon cos of theta. Okay, now let us focus on the denominators and try to solve this 1 minus this, and here also denominator 1 minus this. We'll keep the numerator as it is. So let's continue. This is sin theta the whole upon cos of theta the whole divided by, this is going to be sin theta minus cos theta the whole divided by sin of theta. Okay, plus again numerator we keep as it is, so cos theta upon sin theta, and denominator is going to be cos of theta minus sin of theta the whole upon cos of theta. Okay, so yes, this is the expression that we have got. A little bit complicated, but don't worry, a lot of terms will get cancelled out. So let's see what happens. Now let's rearrange this. This is a upon b, this is c upon d. So let me just, okay, if we have something called as a upon b the whole divided by c upon d, so that is equal to a upon b, okay, and this into d upon c. Okay, basically the c remains as it is in the denominator, b is also denominator, so a upon b is a upon b, and this c upon d you do the reciprocal, that becomes d by c. Okay, very important, try to understand how this is equal to this. Okay, because that's what is going to happen in this rearrangement. Okay, once again we'll try to explain this simple thing. A by b the whole divided by c by d. So what I'm actually doing is, let me use a different color, I'm multiplying the denominator by here d by c, and this also I'm multiplying by d by c. Okay, so now c by d into d by c, that is equal to 1. So that will be, so this will be like 1 in the numerator, and in the denominator, and numerator will be a by b into d by c, which can be written as a by b into d by c. Okay, which is exactly what I wrote here. So important point. Okay, so the okay, let me try to erase with this thing. Okay, okay. So a by b divided by c by d is equal to a by b as it is, and the reciprocal of c upon d, that is d by c. Okay. So now using that, let's try to rearrange this fraction here, this whole term here. So it's going to be a by b as it is. So I'm going to write sine theta upon cos theta as it is, multiplied by reciprocal of denominator. So sine theta, the whole upon sine theta minus cos of theta. Okay, plus the next one is going to be same, the numerator as it is, so cos theta divided by sine theta, multiplied by reciprocal of the denominator, so cos theta minus sine of theta as it is, the whole divided by cos of theta. Okay. Okay, we have made a mistake. We have to write the reciprocal of this. Sorry. Yes. So reciprocal is going to be cos theta and the whole divided by cos theta minus sine of theta. Yes. So now this is our left hand side. Now let's try to compress them. So this is basically sine square theta, the whole upon cos theta multiplied by sine theta minus cos theta. Okay, plus as it is, this is cos square theta, the whole upon sine theta into cos of theta minus sine of theta. Okay, now once again we have this one fraction a plus second fraction b. So what we are going to do is this into the whole thing plus this into this, and then the whole divided by this multiplied by this. Okay, so as you can see, this problem is getting big and big, but again no need to worry, be patient. As you can, let's see what is the right hand side. The right hand side is very small, 1 plus sec theta into cosec theta. So many things or many terms have to get cancelled out. So let's see what all gets cancelled out. So let's continue with our addition of two fractions. So this is sine square theta into, okay, into this whole term. So what I'm going to do now is I'm going to just create a copy of this. Right. Copy and paste. So yes, this is what it is. In fact, I think it's better if I just write it down. Okay. Let's change this. So this is okay. Plus, I'm going to write this plus as it is, and then we have cos square theta into, we have cos theta multiplied by sine theta minus cos of theta. Okay, this whole thing is our numerator. So let me draw this line here. Okay, let me use a highlighter for the sake of easy understanding. So this was our sine theta. This is what has come here. Okay, and then we had this. Okay, sorry, let's bring it here. We had this. This is what has come here. Okay, and the whole. Okay, I have made. Okay, no mistake. There's no mistake. And then the denominator. So the denominator is going to be quite a big one. So it's going to be cos theta into sine theta minus cos theta. Okay, into sine theta into cos theta minus sine of theta. Okay, now this is our expression. Let's focus on this expression. So as you can see, this is sine square theta into sine theta. So sine cube theta. This will be cos square theta into cos theta. So cos cube theta. Okay, and then these two terms will be as it is. So let's write them in a simplified form. So this is going to be sine cube theta into cos theta minus sine theta. Okay, plus this is going to be cos cube theta into sine theta minus cos of theta. This becomes our denominator. I have just done this multiplication, sin square theta into sin theta, cos square theta into cos theta. Rest all is same. So let's mark the line. This is our numerator, and denominator is, yes, denominator, yes, denominator, everything is multiplication. So it's basically cos theta into sin theta minus cos theta into sin theta into cos theta minus sin theta. No complications in our denominator. Okay, now note these terms. Let me highlight. So let's come to this. Now this is our expression. So note these two terms, cos theta minus sin theta, and this is sin theta minus cos theta. So I can write this as cos theta minus sin theta by taking the minus sign here. Okay, let me try to do that. Copy, paste. So everything is going to be as it is. Yes, except for I'm going to change this term. Yes, I'm going to make this cos theta minus sin theta, and then this will be minus. Okay, so in fact let me use a different color. This is going to be minus, and this is going to be cos theta minus sin theta, right? Why I have done this? Because then cos theta minus sin theta and cos theta minus sin theta, they are common, so I can take it out, and then it will cancel with this cos theta minus sin theta. Okay, so focus on this. We have just changed the sign of this term, nothing complicated, nothing fancy. Okay, and now, yes, now we are going to take the common things out. So this was is equal to, so is equal to, so cos theta minus sin theta is the common term, it has been brought out, and here inside we have just sin cube theta minus cos cube theta. Okay, and once again we have our denominator as it is, no change in the denominator. So let me just write it down. It is just cos theta sin theta minus cos theta, then once again sin theta and cos theta minus sin theta. Okay, now some terms are going to get cancelled. As we can clearly see, this cos theta minus sin theta, cos theta minus sin theta, they are going to get cancelled. So, oh, I'm short of space now. Okay, so let me just write the next. So this is going to be sin cube theta. In the numerator, we just have sin cube theta minus cos cube theta, the whole divided by, we just now have cos theta and sin theta minus cos theta into sine of theta. So this is our reduced expression. Now let us create a copy of this so that we can transfer it. Copy. Yes. Paste. Cool. So this is our term now. Sin cube theta minus cos cube theta, the whole upon this, the denominator. Now once again we are going to use another identity, which is a cube minus b cube, and that is equal to a minus b, okay, into a square plus ab plus b square. Okay, this is the identity of a cube minus b cube. So our numerator is going to change into, using this identity, it is going to be sin theta minus cos theta into a square, so that is going to be sin square theta, plus ab, that is going to be sin theta into cos theta, okay, plus b square, so that is going to be cos square theta. This becomes our numerator because we are expanding it, and the denominator stays as it is, no change in the denominator. So this is basically cos theta into sin theta minus cos theta into again sine of theta. Okay, so again quickly, if you look at this numerator and denominator, this is sin theta minus cos theta, this is sin theta minus cos theta, they are going to get cancelled with each other. Okay, that is first thing. Second thing, this is sin square theta plus cos square theta, so that is going to be 1. So once again, let's So I'm going to write it directly. So these things have got cancelled, the orange one, so that is ignored, and this sin square theta plus cos square theta has become 1. So 1 plus sin theta into cos theta, the whole upon denominator just has this cos theta into sin theta. So I'm going to just make a note of that. Cos theta into sin of theta. Okay, so we had a huge term. We had a lot of terms in the numerator and a lot of terms in the denominator. Now you can see it has reduced to a very small thing. Now the only thing that is remaining to do is this plus sign. So we can distribute this denominator over this plus sign. So that is going to be equal to 1 upon cos theta into sin theta, plus this is going to be sin theta cos theta, the whole upon cos theta into sin of theta. Okay, and once again we know that this is going to cancel each other out, so that is going to be 1. So I'm going to mark plus 1 here, and again 1 upon cos theta into sin theta, they can be written as sec theta into cosec theta, and this is exactly what is our right hand side. So it's quite a big expression. The whole screen of my iPad is full. So this was where we started with left hand side, okay, and this was the right hand side we wanted. 1 plus sec theta into cosec theta, we got it. 1 plus sec theta into cosec theta. Okay, so as you can see, the only thing that we have done in this entire problem is we have converted this into sine and cos, and then we just kept on solving, tried to find out the common terms, eliminated them, and in between we got some identities, a cube minus b cube. We tried to expand that, a cube minus b cube, and then we also use sin square theta plus cos square theta equal to 1. So using all these small properties that we have learnt about trigonometric ratio, we are able to prove that this LHS is equal to RHS.